Hello everyone. Today let us discuss the concept of continuum in the field of fluid mechanics. So basically concept of continuum discusses about the fluid property is a continuous function of both position and time. So for example, let us consider a fluid particle in case of a cube. Let us assume that there are a lot of fluid particles in this element, in this domain. So let us consider a small volume of delta V where the fluid particles are basically dispersed or distributed inside this domain. So here we also have an empty space, and due to the interaction between these fluid particles, some fluid particles will be entering entering this volume, and it will be, and some fluid particles will be leaving this domain. And if you consider a small volume, the amount of particles will be changing with for every time. So with respect to time, the number of particles, for example, at time t equals to t naught, you might have 5 fluid particles. At t equals to t naught plus delta t, you might have 7. So here, the as the fluid particles are changing, the mass will also be changing. So but for the same volume, you are having a different densities. And so to rectify this, we are going to consider a large volume such that the density will be constant with respect to uh, density will be continuous with respect to position and time. And let us consider that this is a volume, and this is ratio of mass to volume, which is known as density. So at smaller volumes, what's happening is there is a fluctuation in the densities, and at higher volumes you will be having a constant density. So this is the minimum volume which we will be considering, after which, after this volume, we are considering that concept of continuum is valid. And also let us get to know about the non-dimensional number, which will define the behavior of the fluid. Basically, the number is known as Knudsen number. Knudsen number is denoted by Kn. It is the ratio of mean free path of fluid particle by the characteristic length. Mean free path is nothing but the distance covered by a fluid particle in between two successive collisions. For example, let us consider that this fluid particle covers a distance of lambda to before colliding with this another fluid particle. And let us assume that these fluid particles are in a domain of characteristic length L, and the ratio of these two quantities, ratio of mean free path of fluid particle and ratio and characteristic length, is known as Knudsen number. And this is related to concept of continuum, such that as long as Knudsen number is less than 0.001, which is where we consider that the lambda is way less than uh, lambda is in the comparing in the, for example, lambda is less than 0.001 LC, which is equals to uh, sorry let us consider This is nothing but as long as the Knudsen number is less than 0.001, we will be having a continuous fluid. And the examples of such continuous fluids are like water, oil, etc. Thank you.